And that's basically saying that in the case that your supply, which is 4,000, is greater than your demand, basically this becomes a false. If this becomes false,
Yeah.
then you have to do this equation. And this equation is saying that you take your supply
Mm-hmm.
and you subtract demand
Yep.
and you multiply that times 275.
So that's in the event that the
It's revenue, but it's revenue at a loss
it's revenue at a loss because you're selling it for
less than what you paid.
less than what you paid.
Yeah.
And now, did you say that was for every situation where you don't sell all of the shirts, and it's not if the event is canceled? We're not at if the event is canceled.
Correct. We're not there
Okay.
yet.
So like a real scenario would be she goes to the concert, she's selling shirts, she sells 2,000 shirts but needs to ditch the other 2,000. So what is the revenue that she gets from that?
Exactly.
Okay. Cool.
And then you add on to that the revenue that you got from the sold shirts,
Yeah.
which is this D4 times D8.
Yeah.
And so this is column D4, your demand distribution, times your profit per shirt,
Yeah.
gives you your expected profit.
Okay.
So hopefully you have a solid grasp on that right now.
Why is there nothing listed in Sim 1?
What do you mean?
Oh, you just dragged a number across.
Yeah,
Okay.
sorry.
Cool. No problem.
So that's and that's your risk output. So then you can actually get a chart that looks like probability density, profit before risk of cancellation. So this is kind of a crummy graph, but basically you see this big trend. And what I've done is graphed all three scenarios, the 4, 6, and 8 scenarios.
Mm-hmm.
I've graphed those all on the same graph. On your x-axis, you have the amount of money, your profit, and then on your y-axis, I actually don't know exactly what these are, but it's the probability of certain events happening. It's probability density. So
most likely you will make $30,000.
yes, you will make $30,000 or thereabouts. I think it's a 30,000.
Yeah, somewhere around there.
Yeah.
You make around 30,000.
Yes. If you buy 6,000 shirts, you purchase, or you're gonna make a little. What is that? 46,000. 47?
Yeah, 46, 47.
Yeah. So you're gonna make that, or you're gonna make profit of like 64,000 over if you sell out. These are your max values, right?
Yeah, which are increasingly less likely.
Yes, it's less likely to sell 8,000 shirts, sell them all, than to sell 4,000 shirts, based on your demand, which is dependent on how many people show up and how likely they are to buy a shirt.
So this also takes into account that super high probability is not necessarily that you've sold all 4,000 shirts, but it's that you may have sold 3,500 and then there's an additional 500 you sold back.
Yes.
Or something. So it's taking into account all of those.
Yes.
Okay, good. Cool.
And so, you're more likely to sell at 4,000 than the 8 and blah, blah, blah.
Yeah.
So that's kind of what that's describing. Now we get to the event likelihood, which changes this graph a little bit. But keep in mind what this does look like, where you have this spike, and then a spike, and then a spike. Okay? Now, this is a discrete probability, which I need to... This is what a discrete probability looks like, okay? And what it's saying is you have your X table, which is the outcome. So we set 0 as the outcome of the event does not happen.
Yes.
And it's binary. It's a 0.
The event can only happen or not happen.
Yes, it can only happen or not happen. There's nothing in between.
Yeah.
So those are the two values. But because of, I think, the drug addiction of the main singer of the band or whatever.
Yeah. The internal squabbling.
things of that nature.
He's been sick the last few concerts.
Yeah, shit's gone down. And now we have our probability that is 10% or 10% chance that it's canceled and a 90% chance that it is that it's a go.
Okay, so go is 90%,
Yeah.
canceled is 10, and that's provided.
Yes.
Okay, yeah, I remember that. There's a slim chance.
Yeah. And so what cell was that again?
And now, okay, yeah.
So we have our
So now we're on 7 of
yeah.
them.
So now we're on 7. This is just that discrete distribution. But how we determine what values go into that discrete distribution are there were 5 shows canceled out of 50 shows, which equals a 10% cancellation rate. So risk discrete, and I called it a Boolean because it's but it should probably be like binary.
Yeah, binary is.
Let's do that.
Because Boolean would imply is a set of logic.
Yeah. And so we have canceled, 0 occurs 1. Now you have the probability of each of those events happening. So the probability of cancellation or the probability of occurrence, you set your left value to 0.1 because it's associated with the 0,
The low end.
and you set 0.9 to the 1. Okay? And this is actually what the output, not the output, but this is the proper equation.
Yeah.
So you type in equals risk discrete 0, 1, comma, 0.1, 0.9 inside of the brackets and everything. So keep a mind on that.
Okay.
So that's great. Now you have your. Oh, now let's go back to where we were. Okay. So, oh, and I showed you the. Oh shit! Hold on. What that looks like, and there was a small one on the left which was at 0, and a tall one
Yeah.
on the right that was 1.
90.
Yeah, simple enough.
Or yeah, 1, yeah.
Okay.
Cool.
So that gives you that, and now you have your next. You have your next sim table, which is if you purchase 4,000 shirts, it costs you $17,000. If you purchase 6,000 shirts, it costs you $25,000.
Yeah.
If you purchase 8,000 shirts, it costs you $31,000.
Yeah, and this is just, so this would also equal the negative value of the $12 multiplied by, because that's how much I pay for each shirt.
Yes.
So